All right, so pick up from the last video. We left off with our thresholded image. And again, we threshold it first to obtain all of the gray and black particles, converted them all white. Then we threshold it so that only the black regions turned white. Then we subtracted these two to give us now only the gray regions. So what we're going to do is we're going to analyze this image for the black particles and this image for the gray particles. All right, so we're going to go ahead now and use our segment. And remember, the segment is what's going to actually take and measure and mark all of the particles that we want, and then turn them into a nice colored scale image so we can see which ones we were able to detect. So we're going to send it our original image. So that's kind of the background image of this one. We're sending it the thresholded image that we're going to analyze. And then we're sending it 3 values. Let's go up and look at those. 3, 2, 2. So that's going to be the kernel size, 3, and now the number of times I'm going to dilate and erode. And we put in 2 for those. That creates my background and my foreground images. Okay. And then thresh blur 2. You can see here thresh blur 2 is this image here. Okay. And then what we're calling this image here, when we subtract the 2, it's just called thresh. All right, so we're going to go ahead and do that segment. Now remember, when we did the segment, we had 6 outputs from it. Okay, and then you need to double check what those are so you can give variable names to each. Those variable names, of course, are your choice, but they do have to be in the same order as the output. So we're going to output the marked image, and we're going to output, so this one has just the red outlines of the regions in it. We're going to output our background, our foreground, and our unknown. These are if we just wanted to see the intermediate steps and check and just see what things look like. We're going to have our marker file, which has the array of all of the individual labels for each of the particles. And then we're going to output our colored image. So the colored image uses the marker image to then apply colors to each of the particles. All right, so let's go ahead and run it. And we get this one. You can see by comparing that what we are pulling out here are just the black regions. So there's this little triangular region, this little squiggly region. So this is just getting our black ones. And then we can go ahead and put in the thresh. That was the difference in the two. Oh, actually, I did the whole difference here. Instead of using that variable, I just put in the actual calculation here. So thresh 1 minus thresh 2. Same values here. So this should get our grayscaled. Okay. So there is our grayscaled one. So you can see this gray here is right here. And then these outputs now are I marked all with a 3. And the outputs over here for the black regions I marked as 2s. But that's my segment. Looks like it did a pretty good job. And again, you just play with these values if you want to tweak what's going on in here. Okay, so now that we've got that, what I'd like to do in this case, if you have a single image, then you don't need to worry about this. You just do all this once, you're done, you've got your colored image. Then we can go right to analysis. But in this case, I'd like to take all of my black particles here and give them all the same color. I like to take my gray ones and give them all the same color. And then I'd like to combine this image and this image with the original image. So what I'm going to do is I've got 2 conditions. So markers 2, remember, is for the black particles. And remember that in the markers, -1 corresponds to the red outlines, and 0 sorry, 0 is not actually in the file, and then 1 corresponds to all of the background pixels. And so this condition is going to go in the markers and label every pixel that is greater than 1, not including 1. It's going to label it as true. Okay. So this will then mark all of the pixels that belong to the black particles. This one likewise is going to mark all of the pixels that belong to the gray particles. All right. Then I'm going to go ahead and I'm going to take my original image, my black phased image, and my gray phased image. So these are the colored ones. I'm making copies of them. The reason I'm putting copies here is that sometimes in Python, if I was to directly use these, especially with what I'm going to be doing below, I'm going to end up changing the original image, and I don't want to do that. So I'm going to make copies and change these. All right, so I'm going to take my image for the black phase. Those are the colored image for the black phase. And I'm going to take everywhere where that condition 2, which marked all of my particle pixel positions, I'm going to then take all of those and I'm going to turn them into a purple color. So this is RGB, so this is mainly red and blue, just a little green. So this is like a light purple. And then I'm going to do all the other pixels, so this means not, so not condition 2. So this is your background particles, as well as the -1 interface particles. I'm going to turn all those into black. Okay, 0, 0, 0. I'm going to do the same thing for my gray phase, just using condition 3 now, which was done for the gray phase. I'm going to turn those all into green and blue, no red in it. So this is like a green-blue color, kind of a teal or something. And all others black. And then I'm going to go ahead and take my original image that we're going to overlay these onto. And what I'd like to do is find all of the black particles, all of the gray particles, and then make all of those, in this case, black. And I'm doing this so that when I add these pictures together, I'm going to add these colors onto essentially the black areas, which are zeros, and that's how I transfer my color in. If I left this as white, I'd be trying to add, trying to add these values to, say, white areas at 255. They're already maxed out, and so they would just stay white. I wouldn't see anything. All right, so that's what we're doing there. So then my combined image is just going to be my colored image for the black phase, for the gray phase, and then finally I'm going to add it to my original image. And the reason I divide it by 255 here on the original image is because my original image values, we actually looked at it in the last video, go from 0 to 255, where the black phase and gray phase are both from 0 to 1. So this is just putting it in the same value range. So let's do that and just go ahead and simply plot them. So first I have to run this. All right, I didn't run this for this. That, and then this one. There we go. So what I've shown here in this image is just the black phase and gray phase images. I've summed them together so you can see everything marked out. All the background is black. That way when I add this to my original image, I can get my combined image. But remember, the original image, I'm actually adding it to. All of these particles would actually be black in that one. So that way these would add straight on and give me the color. So there's my combined image, now showing the black and gray regions in two different colors, the purple and the teal. All right, so we've got that now combined. The next step we want to do is to analyze our image. So this was just to make things kind of pretty. let me stop there, and we'll come back, and I can maybe slow down a little bit, and we'll take a look at analyzing our data for this case.